Hello, I'm Fred Oswald at Rice University, and I'm pleased to be offering a course as part of the Karma online short course series called Machine Learning in R, Prediction and Clustering. Organizational research and practice has made great advances in understanding the world of work in various ways, usually by applying traditional statistical methods to their research questions, whether that's through simple predictive modeling such as linear regression and ANOVA, factor analysis such as exploratory factor analysis and confirmatory factor analysis, or through more extensive modeling as you've seen through the boxes and arrows of structural equation modeling, or as you've seen through modern methods like latent transition analysis, latent class analysis, and so on. However, these models could have a couple different problems. One is the models actually could be so simple that complex relationships that exist in the data get overlooked. But there could be the opposite problem, that the models are very complex and they might actually overfit the data where it looks like they fit, but really they've been capitalizing on chance. And if the models were applied to an independent data set, once the coefficients are established, maybe those predictive relationships that looked so exciting would go away. So we need to figure out the balance between model complexity but not overfitting. And that's where machine learning comes in, to figure out that balance and make serious attempts at not underfitting the data, to mine for complexity where it exists, but not to overfit the data as well. So we always need to cross-validate our findings on new data. And machine learning does that in a very systematic and rigorous way. Sorry. The course will focus on two general families of models. One is clustering approaches. So you can think of methods you may have heard of like k-means or glommative clustering or DB scans, a relatively new method. And then in addition to clustering, the other approach is predictive modeling. So where we have a criterion in mind, we're trying to maximize prediction using machine learning methods you may have heard of, such as random forests, lasso regression or elastic net regression, and support vector machines. So these models are interesting, useful, again try to balance, not overfitting but not underfitting, and they usefully supplement traditional analyses used in organizational research. They don't have to take the place of them. They can also be an addition or a complementary approach to looking at a research problem. Sometimes, though, you have to use these methods. So when the number of variables exceeds the number of cases, you can't run a traditional regression, but you can run some of these machine learning methods and glean some insight in terms of clustering and prediction. The Karma short course is a hands-on experience where you'll use R and R Studio to analyze and interpret these clustering and predictive models. And you can go to the Karma website to find links, but it might be simple enough to find R and R Studio through Google searching and downloading for your particular operating system. We'll use openly available data sets. We'll use R code that I've already developed and have commented. And then we'll run and interpret a variety of important machine learning models that, again, do clustering or prediction. We'll do that together. So that way you'll have code, sample data for you to work with even after the workshop, and then you can apply it to your own data as you attack your own research problems. We'll also compare various methods, not just conceptually, but also in terms of performance, in terms of how well models predict and running time issues and other practical points as well. So hopefully by the end of it all, you'll be well equipped to apply these new methods on your own. And I look forward to you joining me in this workshop. Thank you very much.